Okay boys, so we're going to continue with rationalising the denominator. So in this one here, we've been asked to rationalise the denominator of root 2 minus root 3 over 2 root 6. So like we were doing before, this has only got one term in the denominator, so we're using method 1. So we look at the denominator, don't look at the numerator, look at the denominator and find the surd in it. It's root 6. So that's what we're going to times top and bottom by, root 6. So don't forget that when you're doing anything with fractions, if you see a top or a bottom of any fraction with more than one term, it must go into brackets. So that's why I put a bracket around there with the red pen. So now we're going to start to multiply our tops and bottoms. Now because I thought this would be a bit messy on the top trying to multiply this, I've decided to write the root 6 down first, then the bracket, because we're used to expanding it in that order. Alright? On the bottom, I've actually done the multiplication, so we've got the 2, and root 6 times root 6 is 6. So you can see we have rationalised the denominator because all the surds are gone in the denominator. Alright, now we can expand on the top. Root 6 times root 2 is root 12. And then root 6 times minus root 3 is minus root 18. Now at that point, it may be okay to leave it there, but you're never too sure what's going to happen with surds. So what I've done is simplified the two surds on the top just to see what would happen. So with 12, the highest perfect square that goes into it is 4. So it's root 4 by 3. And with 18, the highest perfect square that goes into 18 is 9. So it's root 9 by 2. So when we simplify it, root 4 is 2, so that's 2 root 3. And over here, root 9 is 3, so that's 3 root 2. And as you can see, nothing really changed very much, so that answer probably would have been okay for the question. If they use the word simplify or in simplest form in the question, I think it's really important that we know how to do this anyway, so let's just go right down to that answer. Alright, looking at the next one. Now they've reworded this differently, but it means the same thing. So if they've said simplify, so we've got to give the simplest answer, giving the answer without a rational denominator. Okay, without a rational denominator. Okay, I think they meant without an irrational denominator, so we'll just change that wording a bit. They normally say with a rational denominator or without an irrational denominator. In other words, if it's without an irrational, it's without surds in the denominator. Okay, so looking at this question here. Now, that's the question, and just wait for the bell to stop. I am not going to try and rationalise the denominator of each of these separately. Some people do, and sometimes it works out okay, but I would rather, if I see a question as it is, as that's basically a subtraction of fractions, you think, okay, how do I normally subtract fractions? I find a common denominator. So that's what we're doing here. We're looking at our two denominators and going, okay, what's the common denominator for this? So that's the only whole number that's not under a root sign, so we're going to write that down. And then we've got root 3 and root 2. If you had 3 and 2, your common denominator would be 6. So root 3 and root 2, our common denominator has to have root 6. So that's the first thing I'm doing here, is finding a common denominator. So I've got to think, okay, how did I get from 2 root 3 to get to 2 root 6? I times by root 2. Write it in with your red pen, don't try and do this in your head. Then write the same thing on the top to keep your fraction equivalent. Over here, what did I do to root 2 to get my common denominator of 2 root 6? I times by 2 root 3. I do the same thing on the top. Alright, now if I do these little multiplications, 3 times root 2 is 3 root 2. Don't write root 6. That's not a surd, that is. Keep them separate. Then over here, 1 times 2 root 3 is 2 root 3, and we have a minus in the middle. So we've done our little multiplying on top, we've got our common denominator. Now we're going to rationalise our denominator. Okay, so now that I've got it as one fraction, I'm now going to rationalise the denominator of this fraction. So I'm going to look at this denominator, see the root 6 in it, and times the top and bottom by that root 6. So on the bottom we have 2, root 6 times root 6 is 6, and we'll do that multiplication in a minute. And on the top, like I did before, I'm writing that root 6 down first, and then I'm going to multiply out like I would when I'm expanding. So root 6 times 3 root 2 is 3 root 12, and root 6 times minus 2 root 3 is minus 2 root 18. Now again, like the last question, I'm just going to simplify these surds and see what happens, because you'll see in a minute it makes a big difference, so you don't stop here. So the perfect square that goes into 12 is 4, so root 12 is going to be root 4 times 3, and the perfect square that goes into root 18 is 9, so that's going to be written as root 9 times 2. So going over to here, that's the 3, root 4 is 2, okay, so we've got 2 there, the root 3 is still under the surd. This bit here, we've got minus 2, we just copied it, then root 9 is 3, there it is, and the root 2 is still under the surd. And on the bottom, we've already got that as a 12. Now we're just going to tidy this up. 3 times 2 is 6 root 3, 2 times 3 is 6 root 2. Now, once you get to there is more simplifying that can be done, but you've got to be really good at your fraction work and everything that we've done up to this point. That's why it's really important you keep practicing everything, because otherwise you just don't have the basics to continue at this level. Okay, so when we look at that, you should be looking at those 6's and the 12 on the bottom and going, oh, hang on, I think something's going to happen here. So you'll take that 6 out as a common factor on the top. That will leave you in the brackets with root 3 minus root 2. 12 just stays on the bottom. Now that the 6 is out, you can do some cancelling here and bring that 6 over 12 down to 1 over 2. The 1 you can leave out in the next line, and we've got root 3 minus root 2 over 2 as our final answer. What I don't want you to do is to look at that and start cancelling things here. Okay, you're going to be in a huge mess and you can't do it. All right, on the top here you've got 2 terms. On the bottom you've got 1. We cannot do any cancelling till we have it as 1 term on the top, 1 term on the bottom. And factorising actually makes that 1 term. So because it's now 1 term on the top and 1 term on the bottom, you can now cancel. Okay? So don't try cancelling before that. All right, here we go with another one. Now this time we're going to use the other method. So the other method, just turn this around a bit. The other method is the one where the denominator has 2 terms. So this denominator has 2 terms. Okay, now if you go back to the notes you wrote down that when it has 2 terms in the denominator, we multiply by something called the conjugate surd. Now what that is we keep these 2 terms and we swap that sign in the middle. So because that's a plus sign, we're going to swap that to be a minus, but we're keeping our root 3 and our root 5. So over here when we times our tops and bottoms, it's root 3 minus root 5 that we're multiplying by, top and bottom. Anything with more than 1 term has to have brackets, so put brackets around that, and that. And now we're ready to start expanding. So on the top, I'm just leaving it because sometimes on the top line, if you go expanding it, you'll end up having to factorise again later and you've wasted your time. Okay, so I'm going to leave this at the moment just to see what's happening with the 2 and the root 3 minus root 5 in brackets next to it. On the bottom though, I am going to expand because I need this to become rational. That's what we're doing here, rationalising this denominator. So root 3 times root 3 is 3. Root 3 times minus root 5 is minus root 15. Plus root 5 times root 3 is plus root 15. And plus root 5 times minus root 5 is minus 5. Now, on the bottom, if you've done this right with this method, these two terms in the middle here should give you 0. They should be gone, because the whole idea of rationalising the denominator is that we have no surds. So we certainly don't want these surds hanging around in the middle here. They will eliminate each other and become a 0. So minus root 15 plus root 15, nothing. Okay, so that leaves us with 3 minus 5, which collects to give minus 2. Now, you can see it was a good thing I didn't expand that top, because now it's already factorised and we can now break this down to minus 1 and keep your root 3 minus root 5 in brackets. Now you can just expand it out and there's your answer, minus root 3 plus root 5. Alright, I'm going to do a couple more examples on this second method. So on this one here, there's your two terms in the denominator. So to find the conjugate surd, keep the two terms, swap the sign. So the minus is now going to be a plus, and that's what we're multiplying the top and bottom by, 2 plus root 7. Anything with more than one term on the top or bottom of a fraction goes in brackets. Okay, now, as I said before, we're not expanding the top just in case we need it refactorised to then do some cancelling, so we're going to leave it, but we're going to expand the denominator. 2 times 2, 4. 2 times positive root 7, positive 2 root 7. Minus root 7 times 2, minus 2 root 7, and minus root 7 times positive root 7 is minus 7. Leave the top alone for the moment, and let's look at the bottom. This is what I said before. All of that bit in the middle gives you a 0. They have eliminated each other, like I told you they would. We have no surds left in the denominator. And we've got 4 minus 7, which is minus 3. Now you can just leave that like that. There's no cancelling because the 4 and the minus 3 don't cancel. But they like answers in factorised form, so you don't need to expand that top. Just leave it alone. All right, this next question. People muck these up because we've got 2s and 3s everywhere and they forget what they're supposed to be doing. Just stick to what you're supposed to do. All right, we are rationalising a denominator. We are looking at the denominator, we're keeping the two terms and swapping the sign in the middle. Don't get focusing on everything else. So we're going to keep our 2 root 3 and our 3 root 2. Here they are. And we're just going to change that plus to a minus. And now we're going to start our expanding. All right, so on the top here, we are going to expand and see what happens here, because the way it sits, there's not really anything that's going to cancel at this stage, so we are going to expand. So 3 root 2 times 2 root 3. 3 2s are 6. Root 2 times root 3 is root 6. Next part, 3 root 2 times minus 3 root 2. 3 times minus 3 is minus 9. Root 2 times root 2 is 2. Next part, minus 2 root 3 times 2 root 3 is minus 4 times 3. Remember, root 3 times root 3 is 3. We'll multiply them in a minute. Minus 2 root 3 times minus 3 root 2. Be careful. Minus times a minus gives you a plus. 2 times 3 is 6. Root 3 times root 2 is root 6. Do it slowly, do it carefully. It's really hard to spot mistakes in this work. If you make mistakes and then come back and try and find it, just do it carefully the first time. All right, on the bottom, expanding, 2 root 3 times 2 root 3. 2 2s are 4. Root 3 times root 3 is 3. So that's going to be 4 times 3. We'll do that later. 2 root 3 times minus 3 root 2. 2 times minus 3 is minus 6. Root 3 times root 2 is root 6. Positive 3 root 2 times 2 root 3. 3 2s are 6. Root 2 times root 3 is root 6. And the last part, 3 root 2 times minus 3 root 2 is minus 9. 3 threes are 9. And root 2 times root 2 is 2. We'll do the multiplying for that in a minute. Okay, let's just start simplifying this down a little bit. So I've taken this and collected them. They are like surds, like terms. 6 root 6 plus 6 root 6, 12 root 6. It's like 6x plus 6x, 12x. So 12 root 6. Minus 9 times 2 is minus 18. Minus 4 times 3 is minus 12. We'll collect in a minute. Do our little multiplications here. 4 times 3 is 12. And minus 9 times 2 is minus 18. This bit in the middle, like I told you before, it's always going to be giving you a 0. It's gone. Okay, now just collect a little bit further and we're down to 12 root 6 minus 30 over minus 6. Now, like we did a question or two ago, I can see there's going to be some cancelling happening here because I've spotted that the 12 and the 30 and the 6 have got something in common. They're all multiples of 6. So I'm going to take the 6 out of the top line as a common factor. That leaves me inside with 2 root 6 minus 5. And then you can see the cancelling that's going to happen down here. 6 over minus 6 will be minus 1. And then you can expand it out for your final answer. So don't forget, no cancelling. Factorise first. Then cancel. Because remember, when you factorise, you are creating one term over one term. Okay, so boys, you don't have any official homework this week. However, on Compass, I am putting homework. I am not checking it. But as you can see, how are you going to understand this work if you don't practice it? It's all very well watching me do it, but you actually do need to do it at some stage. So I'm not checking it, but I am giving you your homework for both the lessons that you've had this week. At the end of the week, don't forget to upload the photos of your workbook so that I can see what you've done this week. It has to go in Google Classroom on the Term 3 Week 1 folder that I've set up. Just put all your photos in there for your workbook. Okay, thank you, and we'll see you next week.